This one is multiplication and division of number base. Multiplication and division of number base. All right, multiplication and division of number base. Okay, so now how do we do this multiplication and division of number base? Now, example 1, evaluate 321 in base 6 times 25 in base 6. Let's multiply it together. 321 in base 6 and then 25 in base 6. All right, so if you are multiplying this, normal multiplication process, we start with 5. 5 times 1 is 5. 5 times 2 is 10. We cannot write 10 because here we are operating with base 6. So 10, how many times can 6 go into 10? It can go once, and then the remainder is going to be 4. The remainder is 4. Now, if the remainder is 4, what are we going to do? It can go once, and the remainder is 4. So we write the 4 down. Then 5 times 3 is 15. 15. But remember, if 5 times 3 is 15, remember that 5 times 2 is 10. So 6 go into 10 one time. That one time, we add it up here. 5 times 3. 5 times 3 is 15 plus that one is 16. How many times can 6 go into 16? How many times can 6 go into 16? Okay, 6 can go into 16 2 times. Okay, and if you go into 16 2 times, the remainder is going to be 4. So we write remainder 4. So that 2 times it goes into is what we bring here, and we brought it down. This is a 2 times 2. Okay, so we are done with 5. 2 times 1. 2 times 1 is this 2. 2 times 2 is 4. 2 times 3 is 6. We can't write 6. How many times can 6 go into 6? One time, remainder 0. So we write remainder 0. Then that one time it can go is what we bring down here. So we are going to be adding this now. 5 plus nothing is 5. 4 plus 2 is 6. So it's the same thing. 6 can go into 6 one time. Remainder 0. So write the remainder. That one time, add it to this is 5. 1 time plus 4 is 5. 5 plus 4 is 9. 6 can go into 9 one time. If you go into 9 one time, remainder 3. So we write the remainder. One time that it will enter, we add it to 2. That is 3. Now 3 plus 0 is still 3. So we have 3 here. So we bring this one down. 1 down. Okay, so we have 13305 in base 6. So this is how to do this operation. Example 2, find the product of 1011 in base 2 and 1101 in base 2. Solution, we are going to multiply them out. All right, so arrange them. 1011, 1101, all of them in base 2. We want to multiply 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is 1. We are done with that first one. Go to 0. 0 times 1 is 0. 0 times 1 is 0. 0 times 0 is 0. 0 times 0. 0 times 1 is still 0. We are done with 0. We go to 1. 1 times 1 is 1. 1 times 1 is 1. 1 times 0 is 0. 1 times 1 is this one. We're done with this one. We go to the last one. 1 times 1, under it's direct 1. 1 times this one, shift your hand, is 1. 1 times 0, shift your hand, 0. 1 times 1, shift your hand, we have 1. We add up now. 1 plus nothing is 1. 1 plus 0 is 1. 0 plus 0 plus 1 is still 1. 1 plus 0 plus 1 plus 1 is 3. We can't write 3. Why? Because we are operating in base 2. So how many times can 2 go into 3? One time. And if you enter one time, remainder what? Remainder 1. So we write the remainder. It enter one time. That one time in enter plus 0 is 1. 1 plus 0, 1. 1 plus 1 is 2. We can't write 2 here because we're operating in base 2. So how many time can 2 go into 2? 2 go into 2 one time, remainder 0. So we write remainder 0. It can go one time. Not one time, we add it to 1 is 2. 2 plus 0 is still 2. So we can't write 2 here again. How many times can 2 go into 2? One time, remainder 0. So remainder 0. Then we take that one time, add it to this is 2. 2, you can't write 2 here, so 2 can go into 2 one time, remainder 0. Write the 0. That one time it can it enters is going to be, bring that one time here, bring it down. So the answer is 1 0 0 0 1 0 0 0 1 1 1 1 in base 2. Then the next example, if 2 3 1 in base 4 times 1 0 in base 4 times 1 0 1 0 1 in base 2 is equals to m in base 6. Find m. Now this m is in base 6. This value is in base 2. This other value is in base 4. So our essence, what you are expected to do here, these are special cases now. You have to change this to base 6, change this to base 6. So by doing that, you can be able to know the value of m in base 6 by the time you multiply two of them together. So let's convert this to base 6. Okay, so but before you convert this to base 6, you have to convert to base 10 first. All right. Then convert this to base 10 2. Then from there you multiply the, okay, let's follow it one after the other. Note, since the base of the multiplicand are different, it is advisable to take each number to base 10 before the multiplication can be done. Now let's take this to base 10. This one now. To base 10 is expansion method. If you don't know how to do expansion method, go and check my video on how expansion is done. So look at it very well. So by the time you convert this to base 10, you have this in 45 in base 10. Okay. Also, the same thing happened here. By the time you convert this to base 10, you have 21 in base 10. So this is just the expansion method. You can look at it. If you don't understand what happens here, there is a video I've already explained. Go and find it out. Then now that we have gotten this 2 3 1 in base 4 times 1 1 1 0 1 0 1 in base 2 is the same thing as 45 in base 10 times 21 in base 10. So multiply 45 in base 10 times 21 in base 10 is going to give you 945 in base 10. So we want to convert 945. Remember, our target is to convert this number to base 6. So now, since we have two of them in base 10, we have them single in base 10. Let's convert 945 in base 10 to base 2, to base 6 rather. Then we convert 945 in base 10 to base 6 because m is in base 6. So therefore, to convert from base 10 to any other base, use the LCM method. 6 into 945. 6 can go into 945 157 times. As it can go into this 157 times. Remainder 3. 6 into 157. How many times can 6 go into this? It can enter 26 times. Remainder 1. Also, 6 can enter 6 into 26 can enter 4 times. Remainder 2. 6 can't go into 4, so it's going to be 0. Remainder this 4. So we copy the answer upward. 4 2 1 3. So therefore 945 in base 10 is the same as 4 2 1 3 in base 6. Hence m in base 6 will be equals to 4 2 1 3 in base 6. Okay, so the same thing happened here. If you look at this, discover that, say, calculate 204 in base 5 divided by this is division now. This is division now. All right, this is division now. 204 in base 5 divided by 3 in base 5. Now they are in the same base. Method 1. We have two methods of doing this. The first method to do this is just your normal long division method. but a little different. Okay, so let's look at the steps here. First steps, divide 2. Look at the 2 here. This 2 by 3. Divide this 2 by this 3. But since 2 is less than 3, since 2 is less than 3, we convert 2 in base 5 thus. How do we convert? We have to convert it as thus. 2 times 5, because the base is 5. 2 times 5, okay, raised to power, this is going to be 10. 10 plus 0, next digit. Look at it. This is the next digit. You have converted this already by multiplying it by the base, then plus 0, just like expansion method. Okay, the expansion method plus 0. By the time it is plus 0, it's still the same thing as 10. Okay, so 10, then 10 divided by 3, that it can go now since 10 is bigger than 3. 10 divided by 3 will give you 3, remainder 1. So that is why we have the first 3, this first 3. Okay, we write down 3 and multiply the remainder by 5. Okay, so the remainder is 1, and then add 4 to it. This is the 4. So since the remainder is 1, this is what we are going to do. That is that this 1, which this remainder 1, times the base, which is 5, times 5 plus the last digit. We want to treat the last digit now, plus 4, which is going to be 9. So the 9 divided by 3 will give us 3. So this 9 we got divided by this 3. Okay, so this is 1 times 5 plus 4 is 9. 9 divided by 3 is this second 3 now. Look at the 3 now. So this 3 times this 3 is 9. So 9 minus 9 is 0. So therefore 204 in base 5 divided by 3 in base 5 is going to be 33 in base 5. So this is how it is done. Then the method 2 of it is this: convert 204 in base 5 and then 3 in base 5 to binary. Binary means base 10. So therefore, do your division in base 10. After that, you do your division in base 10 and bring your quotient back to base 5. So this is a long process, but if you can, it's a method you can also use. So first of all, this is in base 5. We convert to base 10. So this is how to convert to base 10. It's here already. It's in the notes already. Look at it. If you don't know how to convert to base 10, I've done video on that already. So look it up. So 204 in base 5 is the same thing as 54 in base 10. 3 in base 5 is the same thing as 3 in base 10. 3 times 5 raised to the power 0. Anything raised to the power 0 is 1. 3 times 1 is still 3. So both of them are in base 10 now. Base 10, base 10. So we can treat them in base 10. So 54 divided by 3, since they are in base 10, 54 divided by 3 is 18 in base 10. So now that we have 18 in base 10, we have to convert this 18 in base 10 to base 5. Let's convert it now to base 5. Since we have done the division is 18 and it's in base 10, but our answer must be in base 5. Since the original division they say we should do should be in base 5. Okay, so now this is what we are expected to do. So we convert to base 6. From base 10 to base 6, same method. 5 into 18 is 3 remainder 3. 5 into 3 can also 0 remainder 3. So the answer is copy upward 33. So this 204 in base 5 divided by 3 in base 5 is the same thing as 54 in base 10 divided by 3 in base 10, which is equals to 18 in base 10, which is the same thing as 33 in base 10. All right, so now this is another example again for clarity. So this example for clarity, let's do it together again. Calculate 334 in base 5 divided by 2 in base 5. They can give you any other base actually. It can be in base 4, base 5, base 7, etc. All right, so our division we have been doing from primary school, all this division is in base 10, but this is base 5 now. So let's use method 1. Method 1, first of all, look at the step. 3 divided by 2. So divide 3 by 2. If you divide 3 by 2 is 1 remainder 1. So we have 1 here. This is 1. So we use that 1, multiply the remainder by the base. Base is 5. So that remainder times 5 plus the next value is 3. Plus 3 is equals to 8. Okay, so 8 divided by 2 is 4. That's how we get this 4 here. See, we got this 4. Then divide it by 2 is 4. So this is the 4 here. So the last digit is now 4. The last digit is now 4. So divide the remaining digit, which is 4. Okay, 4 by 2, which is 2. So that's how we get these 2. So discover that all of this divided by this will give us 142 in base 5. Or you can use method 2. The method 2 is, this is in base 5, so convert to base 10. Also convert, look at this, convert this to base 10, convert it to base 10. Since division in base 10 is easy, then after you have divided them, you can convert from base 10 back to base 5. Okay, so let's do it. That is what this second method is all about. Many people prefer this second method because it's straightforward. Now 334 in base 5, we convert to base 10. Look at the process of converting to base 10. If you look at it very well, I've done video on this already. So converting this to base 10, we are going to have 94 in base 10. So this is 94 in base 10. So 94 in base 10 is, we'll keep it. So 2 in base 5 is still the same thing as 2 in base 10. It's equals to 2 in base 10. So this divided by this, 334 in base 5 divided by 2 in base 5 is the same thing as 94 in base 10 divided by 2 in base 10, which is 47 in base 10. So if this is 47 in base 10, so we are going to convert 47 in base 10 to base 5, which is going to be our answer. Then we convert 47 in base 10 back to base 5. All right, so this is 47 in base 10. To convert to base 5, use the LCM method. So 5 into 47 is 9 remainder 2. 5 into 9 is 1 remainder 4. 5 into this is going to be 0 remainder 1. So copy upward. By the time you copy upward, you discover that you are going to have 47 in base 10 is 1425. See this sentence as 1425 in base 5.